Hello, I am Kobe, and this is my final project for Python for Data Analysis. So for this project, I have decided to use a WikiHow database that I found on Kaggle. What this database does is that it has a bunch of info about WikiHow articles. This first data frame here is directly imported from the pickle file that came from the data frame, and what it plots here in this data frame is just a bunch of articles. These articles don't have much info with them. They just have the article name, but each of these objects in the data frame is actually an object, and each of these objects have many characteristics, of which I extract here in this huge block. So what each of these lines are doing is that it's going to add a new data frame to a new column to the data frame, and what it's doing is taking each value in the data frame, each info value, and taking the characteristic that I want and making the value of the row with that object that value. And here I actually have a data frame with a bunch of characteristics about WikiHow articles. So that's the main way that this data frame came to exist. So down here we have a bunch of rudimentary Panda stuff, but one thing I would like to point out is the popular articles subset. This is the subset that I took, and it includes all values, all articles that had a value views that is greater than 5 million. I point this up because I'm going to be using popular articles later in the project. So I'm reindex. Here I'm finding the null value. So this is the data cleaning portion of the project. So first thing I do is drop all values that don't have a value for co-authors. I believe co-author lists articles are less trustworthy, so I just completely drop them from the data frame. And if we look here from when I re-index the data frame to the titles, this has 19917 rows, and here I have 19821 rows, as shown here. So it removed all 96 rows with a null value in the co-authors field. Next, I'm going to be attacking the lots of null values in the summary column. I'm going to be replacing the null values with a placeholder summary. No summary has been provided for this article. If we look here at the bottom, for I believe 12 and 11 both had null summaries. Yes, they do. They have none in the summary column. And if we look at 11 and 12, gosh darn it, why did you do that? Where am I? Here I am. If we look at 11 and 12, no summary has been provided with this article. So that's a lot of data cleaning. Now I'm going to be doing the histograms. So what I wanted to do was split my data into 3 categories. So I looked at the year values. I had to drop the 2 values with 1, no last updated value, and 2, no year for the last updated value specifically. And I get this arrangement. So what I decided to do was make 3 subsets. The first subset has all values that were last updated in 2015 and 2019. The second subset is all articles last updated in 2020, and the third is all last updated in 2021. So then I make a histogram, 3 histograms even, and I plot them on top of each other. And what these are plotting is, on the horizontal axis is the number of, I believe, views. Let me double check. Years of, yes, views. So these are the number of views that each article had, and this is the distribution of those view values. So this is the first data set, which was articles from before 2020. So the vast majority of them fell into this first bucket, which is like less than 500,000 views, maybe. I'm not quite sure. That's not labeled, but probably not 500,000. It's much less. But you'll notice for all of the data, the histograms, they do this flattening kind of shape. There's like a few values out in this field, but they are almost all here. Same thing with the ones from 2020. They flatten out, and there's sparsely some here. And then in 2021, they flatten out, and there's some sparsely here. Next up is this scatter plot, which this is where popular articles was used. I used popular articles, plotted views on the independent axis, and the percent helpful on the vertical axis. I wanted to see if more popular articles got more trolls that are more willing to vote negatively for an article. This plot doesn't really have that much of a correlation between the 2 variables, so I would say there's not really a huge relationship between the 2. And finally, I have, oh, my bad, there's one more. I have a line graph where where I plot three different values for articles from 2021. The percentage of helpful votes, which, as this note here says, they're taken out of 100%, thus they cannot exceed 100, which none of them do. Green is the number of references even, they don't exceed 25 anywhere. And then blue is the number of votes. So I took the average of all of these three numbers for all articles on a specific day. So this is the average value of votes for all values in this day in February 2021 of articles that were last updated. This is the average number of helpful votes for articles that were last updated on this day in February, and this is the number of references, the average number of references even. And that keeps going until early July. And then finally, this is probably my favorite part about the entire project. I have a bar chart of the 50 most popular WikiHow articles according to this dataset. There are some very unsavory ones, so I wouldn't look at this too long unless you want a good laugh. So I just plotted views on the horizontal axis and then the articles on the vertical axis. And that's what this is. Here I made the hierarchical index. I chose number of methods and is expert because those were the two main columns in my data frame that have repeating values. Here I'm grouping by the number of methods, and I'm taking the mean summary statistics. I'm unstacking the previously... Actually, no, I'm not. I am taking the views columns from this hierarchy, and I'm unstacking it, which took the... where is it? Nope, I took it from here. It took the last column is expert, that is an index, and then made it a column. So, if we go back down here, the columns are the two possible values for is expert, and the two hierarchical rows are the hierarchical rows from before. And for each record, it's going to plot the row number and the number of methods. And then if its is expert value is false, it's going to place the v value in the false column, and if it is an expert article, it's going to put it in the true column. I remade the same exact thing with pivoting. So what I did was take a copy of the hierarchy, placed a copy of the index as the first index, and then the number of methods as the second index. I made the columns the possible values for is experts, and then plotted views in the value fields, and this is the same exact thing as I just did. Here, I'm taking the count of all... I grouped the entire database by number of methods, so this is the count of all articles with this number of methods. The highest number in this row is the total number of articles with this many methods, so there's 11,374 articles with 3 methods. But there are also some null values, such as in the references column, you're going to see, well, for almost all of the number of methods, that this number is less. So this is the number of non-null values in for all records with this number of methods. I then unstacked this, which took number of methods, and then placed it as the lowest level of column. And because there's no row left, it just becomes a series, because it's one-dimensional now. So we had number of methods and info. So this was the pre-existing columns, and then this is the number of methods, which was the rows, and that is the lowest level of indexing. I create 2 subsets of the data frames here, and I dropped all the articles in the first subset that have more than 4 methods because I'm indecisive, and if there's more than 4 methods, and I just can't decide. Here I concatenate the 2 subsets that I just made. And at the bottom, you'll notice there are null values in the left half, but they're not null for the right half. What happened here is that the concat method took all columns from the first database and then tacked all columns from the second database onto the right side of it, which explains how there got to be 2 info columns. Because the first database ended early, because there were less values in it, all the values that are present in the second database, but not the first, are tacked onto the end with null values with all the columns from the first dataset. I then merged the 2 databases on the info column because that's the one thing they had in common, and that gave us this, which is just combining the 2 databases into one database. Now, I didn't specify a how parameter, so it defaults to inner join. What an inner join does is that it takes all of the values that were in both of the databases. So if the value was absent in sub 1, it's not here. If it's absent in sub 2, it's not here. So this is 18,758 rows. These are all the rows that were in the first database. Now I'm doing a right join, which is going to be all values that are in the second database. It doesn't matter whether they're in the first database. And because we didn't remove any values from the second database, this is going to have more rows. Here I'm going to replicate the hierarchical index pivot with the pivot table. So I passed in the data frame for the data, and the same index rows, the same columns, and the same values, and it's the same thing. I make a pivot table, and because I didn't specify an aggregation function, this is the mean values. So for the So what I did here is that I plotted views. For each row, I have an all column, which is the average number of views for all values in the row. And then for the columns, I have an all row, which is the average number of views for all articles that were false is expert. Didn't matter which row or methods they were. And then this is the average number of views for all articles in the database because it's taking the average of all possible averages. I changed the agg function to sum here, so it's taking the sum of all values in the rows and putting in the all column, then all values in the column, putting in the all row. And finally, I create a cross tab with year on the horizontal axis and is expert on the vertical axis. So at the intersection is the number of articles that were made in that year and has the specific is expert status. So there are 58 articles that were last updated in 2018 that are not expert. And there's 4,774 articles that were last updated in 2020 that are marked as expert articles. And then the sums, the margins are also here. And finally, here's the heat map. As expected, they concentrate near the bottom because more articles were last updated in these years. Okay, that is my presentation. Thank you for watching. Have a great day.